Right now, NGC 4993 is still glowing with the aftermath of the most violent collision ever witnessed by human science, and NASA, Harvard, and Caltech have no way to stop what it triggered. The shockwave is still expanding. The remnant is still unresolved, and every single gram of gold you have ever touched was born in a moment exactly like this one. But here's what nobody is telling you about what they found at the center of it. NGC 4993 is a lenticular galaxy, a smooth, aging disk of ancient stars with no real arms, no drama drifting through the constellation Hydra. It sits 130 million light-years from Earth. To most astronomers, it was invisible, unremarkable, one of billions. Then on August 17, 2017, everything changed. At 8:41 in the morning, the LIGO detectors, two of the most sensitive instruments ever built by human hands, picked up a ripple in the fabric of spacetime itself. A gravitational wave. Scientists scrambled, telescopes swiveled, and within 11 hours they had a lock. The signal was coming from NGC 4993. Two neutron stars collapsed stellar corpses, each heavier than our sun but compressed to the size of a city, had been spiraling toward each other for over a billion years. In that moment, they finally hit. What followed was a kilonova. That word sounds controlled, clinical. It isn't. A kilonova is a detonation so energetic it dwarfs any supernova you've heard of. For a fraction of a second, the collision point burned hotter than a billion suns. It ripped atoms apart and fused them back together in combinations that only exist at the absolute edge of physics. And in that chaos, in those few seconds of impossible heat and pressure, something was made. Gold, platinum, uranium, lead. Every heavy element too massive for a star to forge on its own spewed out of that single point at a fifth of the speed of light. The estimates staggered scientists. One collision, 200 Earth masses of pure gold. Produced in less time than it takes you to blink. Astronomers had suspected this for decades, but watching it happen, measuring it in real time, broke something open, because the numbers were wrong. The models predicted what a kilonova should look like, how bright, how fast it should fade, which wavelengths should peak when. For the first week, NGC 4993 followed the script. Then it didn't. The X-ray afterglow, the jet of superheated material screaming outward from the collision site, kept brightening. For 8 months, it rose when it should have been fading. Harvard astrophysicists published papers, then revised them. The Chandra X-ray Observatory kept watching, and the data kept defying prediction after prediction. But that's not even the part that worries them. Here is what scientists found inside NGC 4993 that they're still not ready to say out loud. When two neutron stars collide, the physics only allows for two outcomes. Either the merged mass is too heavy and it collapses instantly into a black hole, or it's just light enough to survive, a hypermassive neutron star, spinning so fast that electromagnetic force holds it against its own gravity. For a few seconds, maybe minutes, they do not know which one happened at NGC 4993. This matters more than most people realize. If a black hole formed instantly, the gold production window slams shut in milliseconds. If a hypermassive neutron star survived even briefly, it doesn't just hold together, it acts as an engine. It pumps energy into the expanding shell. It changes the chemistry. It changes how much gold is made, where it goes, and how far it spreads. The difference between those two outcomes could rewrite every model astronomers use to calculate how heavy elements form across the entire observable universe. And here is the strange part. It shouldn't be this hard to tell. The signals should distinguish themselves. But the data from NGC 4993 sits right on the edge of both possibilities, and the jet is still expanding, still radiating, still producing an X-ray signature that doesn't match any theoretical framework built before August 17, 2017. They are not just watching an event. They are watching the universe contradict itself. Think about what that means for you. Every gold ring, every platinum circuit in your phone, every atom of iridium in the catalytic converter of your car, all of it was born in a collision like this one. in neutron star mergers scattered across billions of years of cosmic history. The gold in your hands is older than the solar system, older than Earth itself. It survived the death of stars, the chaos of galaxy formation, the slow collapse of ancient solar nebulae just to end up here. And the terrifying part, we don't know if we have the right amount. We don't know if our models of our process nucleosynthesis, the chain of reactions that forges gold in the first place, are even close to accurate. NGC 4993 has already broken 3 models since 2017. The universe is not following our equations. So here is the question that keeps astronomers awake at 3 in the morning. If one collision in one ordinary galaxy produced enough gold to bury a planet, and we still cannot explain what is happening inside it, then what else is being made out there right now, in ways our physics hasn't even imagined yet? Drop your answer in the comments, because NGC 4993 is still glowing, and the universe is not done rewriting itself.